Saturn has an extensive ring system. It's the largest in the solar system. The rings are made up of small particles. Most are pure ice at temperatures between -200 and -160 degrees Celsius. Surprisingly, though, astronomers still debate how and when they formed. The leading theory is the rings are a former moon or comet that came close to Saturn. But this theory has some issues. It doesn't explain why the rings are so thin, or why they've maintained their shape for so long. It also doesn't explain electromagnetic phenomena found by NASA's Cassini probe. In a new study, scientists Vladimir Tchernyi and Sergey Kapranov take a different approach. They suggest the rings are former pieces of Saturn's protoplanetary cloud from the early days of the planet. Here's the controversial part. They think it's possible that when Saturn's magnetic field became active, it could have interacted with icy particles in orbit. This interaction may occur because icy particles are diamagnetic. This means they're repelled by a magnetic field. We've long known ice is diamagnetic at low pressures since the property was discovered in 1962. The two scientists think Saturn's rings could be stable because of this. With gravity pulling in and the magnetic field pushing out, the particles are superpositioned between the two forces. Past research has shown that diamagnetic objects travel to the weakest area of a magnetic field. That's where the rings happen to be, and the authors don't think this is a coincidence. The scientists' calculations also suggest gravity alone couldn't maintain ring stability. If you follow this subject, you might be wondering about the Cassini data that suggests some rings are new. Magnetism may provide an answer to this too. In 2005, the probe discovered water-rich plumes were venting from the south pole of the moon Enceladus. Cryovolcanoes there shoot water vapor and ice with enough velocity to eventually settle in Saturn's E ring. The authors think most of the rings are relics of Saturn's early days, but new materials can always enter the ring system and refuel them. Magnetism can also explain strange spokes discovered in the B ring by Voyager 2 in 1981. The force of gravity has been used to explain the spokes without a real consensus. It's possible they occur when ice particles pass by anomalies in the planet's magnetic field. So what about other outer planets? Magnetism may also explain the rings of Neptune and Uranus, as both are thought to consist of ice particles. Jupiter's rings, however, are different. They're faint and mostly made of dust. At the low temperatures seen beyond the asteroid belt, however, it's possible the particles interact with Jupiter's magnetic field through a phenomenon called superconductivity. A 2018 study from the University of California, San Diego suggests superconducting materials exist in meteorites. This material could exist in Jupiter's rings, allowing it to interact with a local magnetic field. It's been suggested in the past that Saturn's rings can't really teach us anything new, that scientists only study them to solve the mystery of their origin. But if Tchernyi and Kapranov are correct, magnetism could be an important part of planetary evolution. It could even give us a better idea of the kinds of rings around different exoplanets.